I'm going to be doing a brief overview of the methods section of my paper. My paper is about multiscale modeling of chemical systems via neural networks. Now, the purpose of this overview is to help better explain, like I mentioned, the methods section, and just give a clearer picture of what's going on. And I also made some animations to better show that. So this is just an overview page. It just shows the general process that the system is going to be following. Now, if you don't know what a neural network is, basically it is a type of system that takes input and it relates it to output. So, for example, with this model, what we are trying to do is simulate atomic data. So we're trying to figure out how atoms are moving and reacting over time. And the way we are going to be doing this is by using a neural network type architecture, where we feed it the atoms at, say, time step 1. And we want to see how those atoms will be different, like in terms of their location, at time step 2. So that's what this neural network is doing, is trying to predict that. It's trying to relate the input at time step 1 to the output at time step 2. And if we feed it enough information about how these atoms tend to move over time, it eventually learns how to perform those simulations on its own. So this gives an overview of how that works. So first, we are going to feed in atomic data in the form of atoms and their trajectories. Next, that atomic data will be converted by a neural network into a vector representation. So all this is, it's just a form that's readable by other neural networks. Next, we are going to perform a prediction. We will have another neural network that does this. Now, this other neural network, like I mentioned before, all it's doing is trying to predict from, say, time step 1, what is going to happen at time step 2. And this grid kind of shows that. So this represents how those things are changing over time. And we will end up with prediction results from that. Next, what we are going to do is we are going to be compressing that information, the results, into a smaller representation. All right, so we're going to be basically converting that prediction into a smaller representation, and we are going to do this by another neural network. That another neural network will take in these prediction results, and it will compress those into a smaller size. And so that's what this represents. So we can see that original grid, which was this large, is compressed by the network to now be represented in this small cell. And so this area overall is a lot larger of a simulation area. And so next, all we're going to do is repeat all of these steps for every single cell in this grid. And that basically means that we can be simulating large areas over a large time scale. So basically, something this large is now represented in just a small little square, meaning that we can have a lot of atoms that we're simulating. So we run through all of those simulations, and we end up with something like this. Now, the different colors, they just represent different predictions that we might be getting. And then what we need to do is we just decompress that data back into its original format of atoms and their trajectories, except now, as you can see, we have a much larger area over which we're predicting. So looking here, we can see that this original atomic data would actually fit in maybe right here. And that's how much smaller it would be here. That's how much larger, I should say, this whole area is compared to that. And so here we are going to be seeing a quick animation of how this process works. This first animation is showing how the data is translated into a form that's readable by the neural network. You're going to be seeing a blue square rastering over a grid. And basically that just represents the neural network performing operations on the data to convert it into a form that's readable by other neural networks. All right, so now we have a form that's readable by other neural networks. Next, we are going to be running another neural network over this data, and that other neural network is going to be predicting how the atoms will be changing in their position over time. And then after that simulation occurs, we are also going to see how the data is compressed and how a larger scale simulation is performed. So this is the compression. These are predictions for a whole bunch of other neural network grids, and then we decompress the data, and this is what we get. Now, using this architecture basically allows us to simulate over very large areas. We can just repeat this process on this data now, for example, and get predictions on a very large scale. So the idea is this process can be applied again and again to simulate larger and larger scales in terms of time and size. So let's just watch that one more time. All right, hopefully that gave a bit more understanding in terms of how this method actually works. Thank you for your time.